I'm Bruce Carl. I'm an application engineer with Mentor Graphics, and today I'm going to talk to you about power integrity analysis. I'm going to start with our DC analysis. This is used to analyze voltage drop across a plane and current density in a plane. So I'll start off with our simulate power integrity, and I'll run our DC drop product. I'll select the 2.5 volt plane for our analysis, and you can see it's selected here. And I'll go ahead and click the simulate button. It quickly does the analysis. It's one of the fastest tools on the market. It'll show you all of the voltages at all the pins and currents through all the vias. And also, if I go to our display and expand this out, you can see a three-dimensional view of where all the voltage is across the plane. And you can see right here that as it gets into the center of the FPGA, that's where you have your most voltage drop. Now, we also do AC analysis very quickly on the same kind of plane. So I'll go ahead and start up our AC analysis. So first I'll close these windows out, and I'll do simulate power integrity and our decoupling wizard. And this brings up a wizard interface where you can assign your capacitor models, and it'll do an analysis of the plane where it will tell you what the impedance is between the plane and its reference. So now you can see that our decoupling wizard's up. I'll select the nets. We're going to do the 2.5 volt plane again with respect to ground. On the next one, I assign the capacitors in groups. So all the capacitors are grouped. I assign a model. Could be RLC model, S parameter, or SPICE models for that. I'll go ahead and pick that we want a distributed analysis that includes all of the effects of the plane, spreading inductance and so forth. And I'll select that we want these two devices, this U24 and U30, where we're going to calculate the impedance that those two devices see when they pull power out of the plane. And we'll set this up for just a logarithmic sample and say run. And so now the analysis is running now in real time. We're going to sweep from almost DC up to 150, well, from about 1 megahertz to 150 megahertz. And we'll have a plot here in a second that'll show frequency across the x-axis and impedance across the y-axis. So here you can see for the first IC that we're about 10 milliohms of impedance, and we see the profile across up to 150 megahertz. And then for the other IC, we see this curve that shows the impedance that IC sees. So that's my presentation on power integrity. And you can see more about this at Mentor's website at mentorgraphics.com.